Добрый день, уважаемые коллеги. Я из Узбекистана.
Good time of day, dear colleagues. I'm from Uzbekistan, Doctor of Physical and Mathematical Sciences, Professor Otajan Salim Madahimovic. Today's report at this conference is called Creation of an Optical Sensors based on the p-cadmium tellurium and cadmium sulfur and p-cadmium tellurium and cadmium selenium heterostructures for detecting polluted air. Optical sensors is a new heterostructure photodetector based on the p-cadmium tellurium to n-cadmium sulfur and p-cadmium tellurium to n-cadmium selenium for determining air pollution. This is an automatic control system using Arduino designed for supply and exhaust air ventilation. The largest sources of the aerosol emissions into the atmosphere are workshops using cook ovens. The optical properties of the heterostructure showed that the absorption spectra of cadmium telluride doped the first group of elements shift to a longer well-light region up to 0.6 electron volt of the spectrum, and this gives ground that the photovoltaic operates in the impunity absorption region. If a semiconductor crystal is illuminated, this light has such a frequency that the photon energy is equal to or greater than the energy gap of the semiconductor. The incident photons have sufficient energy to excite electron-hole pairs, which increase the conductivity of the crystal. This increase in conductivity is a function of light intensity and this increasing intensity as a photon is absorbed for each electron-hole pair created. In this regard, in this work, the optical parameters of the created sensors based on the heterostructure for determining air pollution were investigated. For cadmium tellurium films, elements from the first group, silver and copper, were chosen as doping impurities. The selection of the metals as impurities is due to the following reasons. Firstly, the optimal diffusion doping temperature of silver and copper is cadmium tellurium is relatively low and lies within the substrate temperature range of 80 to 300 Celsius, which allows for obtaining cadmium tellurium films with the highest photoconductivity and stable characteristics. Secondly, these impurities are necessary to neutralize surface status and influencing the barrier between crystallites. It can be assumed that in crystallines barriers are optimized without recording our maximum photoconductivity value, and the crystalline size is also optimized.
Предлагаемые оптические датчики для обнаружения загрязнения воздуха содержат основания.
The proposed optical sensors for detecting air pollution contain a base central shroud hole on the lower and upper surfaces. Inside the sensor, where polluted air particles pass through, and IR LED is placed. The emitted rays from the LED pass through lenses and hit the surface of the polluted air particles, while the rays that do not hit the particles are reflected by a mirror located inside the opposite wall of the sensor. Thus, the rays emitted by the IR LED maximally hit the polluted air particles, and the rays reflected by the particles pass through lenses to the photoconductor based on the heteroconstructive. In the absence of air pollution, the light emission from the source directly hits the photoconductor through the reflecting mirror, while the background light is extinguished in the reflecting cells, which act as traps for light. In these cells, almost complete sublimation of the parasitic signal from the IR LED and incoming external light occurs.
Способ изготовления полупроводного датчика с новым гетеротрутным фотоприемником для обнаружения загрязнения воздуха.
The method of manufacturing a semiconductor sensor is a new heterostructure of a detector for detecting air pollution is as follows. The semiconductor sensor is made from plastic material for the body with a metal cover for electromagnetic field protection. Inside the body, there are semiconductor elements, a block diagram for controlling the IR LED, and amplifier circuit and a glass mirror for reflecting the IR beam. The optical sensor is small in size within the 17 grams, which has been reduced from the prototype weight by using new parts such as a reflective mirror and photodetector with a new heterostructuration, making it suitable for installation in hard-to-reach places.
На рисунке 1
Figure 1 shows the block diagram of the sensor with a new heterostructive photodetector for detecting air pollution, which helps to easily understand the important components of the sensor circuit. Inside the working area of the sensor, four main components are located: the infrared light emission diode LED and the photodetector, or replaced by the new heterostructive photodetector, the reflecting mirror, first used in the sensor, and pair of lenses. The LED, then the photodetector are positioned within the sensor so what their optical axis intersect within the sensor's detection area with the help of the reflection mirror. When polluted air enters the sensor detecting area, the light inside the sensor reflection of dust or smoke particles, and the amount of detected light varies depending on the density of the particles. The generated current by the photodetector changes accordingly. The output voltage compared to the density of pollution and smoke particles is shown in the figure 2. This device model different from other prototypes in the following ways. The opaque participation in the pollution particles in the intake chamber are made in the form of radially oriented plate ribs, the internal end section of which are located near the salt hole of the base, forming stained salt channels for the passage of pollution particles and gas. The smoke intake chamber contains a plate bottom, the area of which corresponds to the area of the salt hole in the base. Instead, under the specified hole at the level corresponding to the level of the lower surfaces of the funnel, with the formation of a slot gap for the penetration of pollution particles and gas. Indifferent from the used sensors, which consist only of silicon photodiode, these lenses and amplified unit as follows. New sensors with a heteroconductor photodetector for determining pollution particles in the air containing about the central salt hole on the lower and upper surfaces, and inside the sensor where polluted particles pass in there is an IR LED, which when emitting rays shows the lenses hit the surfaces of polluted air particles, and which rays that do not reach are reflected by a mirror located inside opposite the wall of the sensor's rays. After the rays reflected by particles of polluted air enter, though the lenses of a photodetector based on a Phi cadmium tellurium to the N cadmium sulfur heterostructurate. The sensor systems, the emission line of the IR LED and the line of reception of the rays reflected by the particles and located at an angle of the 19, which reduces the sticking of polluted air particles to the lenses and to the reflecting mirror. In conclusion, it can be noted that the created sensors based on the cadmium tellurium heteroconstructive have a number of advanced over existing sensors. This heteroconstructive sensor operation by first in the wide range of received electromagnetic radiation extending to the near infrared radiation of spectrum 0.4 to the 3.0 micrometers. For second, due to the addition of silver imputability, the signal and current power increases, and for third, photosensitivity increases with the addition of the silver imputability, which photoconductivity appears in the imputability absorption region. At this point, I finish my report. Thank you very much for listening to my performance, and I wish you success.
Желаю вам всех успехов.